Okay, I think that's a reasonable cushion. So welcome everyone to today's webinar entitled How QA/QC Bridges the Gap Between BIM and Field Reality. We want to thank you for taking the time out of your busy schedules to attend. My name is Gene Rowe. I'm the founder of Lidar News. I'll be your host today. We also have Alex von Svoboda from Solidspac3 and Li Jiang from Dome Construction. There will be more detailed introductions when we get to those that part of the agenda. So the usual housekeeping items. The controls for the Zoom webinar are in the footer. Everyone is muted. Please use the question and answer logo to ask your questions. If you do get disconnected, I would go back to the original invite. We will be recording. We are recording the session so that we can make it available. There will be 2 polls and a exit survey, which we encourage you to fill out to help us plan for the future. Today's agenda, there will be the 3 of us. I'm going to make a few comments on how we're going from the AEC world to the built environment. Alex is going to give you a brief product overview of the Solidspac3 software environment. Excuse me. Li Jiang will provide a case study about her work at Dome Construction using the Solidspac3 software. We have a couple of short poll questions. Let's just get those out of the way. I'm going to launch the first one here. Okay, first question, what is your current job title? So if you could give us an idea of, okay, it's working, very good. Don't need to have this open very long, I don't think, but looks like we may not have come up with just the right categories because other is 55% at the moment, and the rest are pretty even. But let's give it a couple seconds. And I think everybody's in, so we'll end the poll and share the results. And as you can see, other is the clear winner with, I guess, VDC and BIM Manager coming in second, which is good to see. So we're going to stop the sharing and go right on to the second poll here. Are you using BIM for VDC pre-construction coordination today? And that's just one choice that you should make there. So we're going to launch that. Okay, I should have. Are you using BIM for VDC pre-construction coordination today? Still getting voting. I want to try to get everyone that we can in. I think we've got most people. So let's end it, share it. What do we have? All the time is fairly high at 29%. Never is 32. So there's some opportunity there for us, I guess, to explain some things today. Thank you all for taking the time to fill those out. So that's the poll questions. Okay, so my goal in these next couple of slides is to just get you thinking about the transition, the transformation, the digital transformation that we're making, not only from a technology point of view, but also from a business model point of view. I've highlighted the word environment because there's a lot of work that needs to be done in just the environment side of things, but that's, we'll have to leave that for another time. So from the slide rule to the metaverse, I got a BS in civil engineering with just the slide rule. So that tells you that that was before the mid 1970s. The other thing I want to really stress in my short talk here is the transition from 2D to 3D and 4D and on, and how far we really have come over, in my case, the past 50 years, but yet how far we really have to go in many ways. So depending on your age, you will be able to relate to some of these things, like the 100-foot steel tape and plumb bob, or maybe not in the 70s. So just quickly running through the kind of key items that, in my opinion, stand out in those decades, such as the calculator, an electronic distance measuring device, which was a tremendous game changer for those of us pulling 100-foot or 200-foot steel tapes. But it was all one point at a time. It was still 2D. In the 80s, I had some $10,000 total stations that completely changed my surveying business, as well as CAD, AutoCAD for $1,000, for instance. In the 90s, I'm thinking GPS, facilities management, was a type of software where people were starting to get the idea of BIM, but they really didn't have it yet. But then in the 2000s, we're seeing this major breakthrough from 2D to 3D, namely in the form of 3D laser scanning, airborne Lidar. And then on the software side, in building information modeling. Of course, the internet was, it is a key part of this transformation. In the teens, we saw greater use of kinematic scanning in terms of mobile vehicles, mobile systems, wearable systems. Maybe that's more in the 20s, but certainly 3D modeling. UAVs definitely changed the game as well. And now we're in the 20s, where the cloud, autonomy, especially in the case of autonomous vehicles, artificial intelligence, machine learning, and the metaverse. I don't know if we'll ever be surveying in the metaverse, but I guess we'll have to see what happens there. More importantly, I think, is the realization of the business model transformation that's taken place over these past 40, 50 plus years, which I really believe, when you analyze it, is driven in large part by the availability of 3D technology. So for the first, I've seen graphs from the early 80s up into the 2000s, where most other industries were gaining tremendous productivity from digital technology. The construction industry did not. In fact, if anything, it declined. Part of the reason for that is the AEC business model. The old traditional AEC business model was not a very beneficial one for a lot of people. It was in many ways based on antagonism and things like change orders and back charges. And then if it didn't work out, you ended up in litigation. somewhere maybe 15, 20 years ago, value engineering and the idea of constructability started to emerge. But it was really the visualization that you got from 3D technology, from BIM, for instance, that led to this new approach, this new business model that's largely based on what's called VDC, virtual design and construction, or IPD, integrated project delivery. Now people can collaborate. They can really see what is going to need to be done to build the particular building, infrastructure, highway, bridge, whatever it might be. And there's also a shift, excuse me, to more of a collaborative environment, to the point where a contract is signed before the work begins, specifying that no change orders will be allowed on the project. Now that's radical change. And as I mentioned, it's not just 3D. To have that kind of collaborative environment, you need to also look at schedule, you need to also look at cost, and there's other factors that people come up with for 6D and on and on. But as you're going to see, the concept of variance reporting, that is, how does the design BIM compare to what's actually being constructed? That's the key. If you can find those variances early enough, you can avoid the significant costs that plague most construction projects. But we're not finished. There's still many issues out there. There's a real lack of standards, data models, data interoperability. National Institute of Building Sciences has come up with a national BIM standard for the US. They're working with the UK, where there's a BIM standard for all public buildings. That's a requirement now. So work is being done, still have a ways to go. Okay, at this point, I'd like to turn it over to Alex von Svoboda. He's the Vice President of Sales at Solidspace. Alex brings over 25 years of experience in the AEC and owner technology sales and marketing experience. I've known Alex for most of those 25 years. We started out at a little company called DCA Engineering Software, which became Softdesk, but that's another story also. His experience spans Fortune 500 software companies to startups where he's helped launch industry-changing products, prides himself as a trusted advisor to his customer base, building strong, ongoing relationships to help grow their businesses. So I'm going to stop sharing and turn it over to Alex.
All right, thanks, Gene. I appreciate that. I had to have a little chuckle while you were going over your history, and because I started not with a slide rule, but definitely the 100-foot chain in the plumb box. Anyways, hello everyone, and thank you for attending today's presentation. My name is Alex von Svoboda. I'm the Vice President of Sales here at Solidspace. We have a great customer success story today with Dome Construction that really highlights our Solidspace variance reporting SaaS offering for QA/QC as part of the BIM workflow to help bridge the gap between BIM and field reality. So that is a big thing that is new that we want to expose everybody here on this call to. So what is Solidspace? Solidspace is a construction technology software company that produces variance reports primarily. That's what we do. And the variance reports help contractors ensure that plans match reality, enabling them to build it right the first time. So we do this by identifying mistakes during construction in a timely fashion to ensure what is built matches the design intent. So we all know that mistakes happen during construction, and sometimes they tend to be very expensive. Solidspace is focused on minimizing rework, which leads to more administrative tasks like RFIs and change orders, schedule delays, and could be big claims. So that's what we're trying to help reduce. So our solution analyzes plans against reality in the cloud. So it's a very easy to use solution. Just upload your BIM, Navisworks 2D, 3D drawings, scan the desired area, and upload that scan to our online application called Space. And in less than 12 hours, you will have variance reports to use in the field and make corrections. So this is what it looks like. So this is a typical example of a variance report. So Solidspace helps that construction team while they're there on site in the area, informing them of the problems as they occur and before they become expensive and start delaying the project. So variance reports are created with easy to understand visual images that inform the contractor where the issue is, what is the deviation, and how to correct it. So you can see it on the slide here with the different views of the variance part, telling you where it is, and what to do about it. So variance reports can be done on a number of different components or trades. So like architectural could be walls, doors, windows, floors. Structural could be columns, beams, eye-downs. MEP for ducting, electrical, plumbing, fire protection, and process piping trades. So in this case here, you see on the right, we actually have a variance report for floor flatness in a heat map format. Just another example. The previous variance reports I just showed you are used with the field team primarily. But the VDC and BIM teams can also use our Space online application that stores those large files like the scan file, the BIM models, and drawings. But the unique thing here is by clicking on the variance report itself, like you saw previously, and hitting the image, you can actually enter the model in directly. So now you're actually in the model, and you could do walkarounds in 3D, measure certain components that you're investigating. So all this can be done in real time. So this can help you eliminate possibly additional site visits when more information is needed. Users can view the files directly. No need to download locally the big files or use other applications. It's all done in our application in Solidspace. Solidspace has a number of key customers you can see on this slide here that use our product continuously today. We typically work with GCs, owners, and some trades. And now we're seeing a trend of working more with companies that do prefab components that need more precision for correct installation in the field. All right, so here we go. Okay, I'm very pleased to introduce our guest speaker today. For today's webinar, Li Zhang is a senior BIM engineer at Dome Construction with lots of AEC domain expertise, constructing life science projects with high complexity. She holds a PhD in architectural engineering and a master's in construction management. So with that, I want to welcome Li, and you can take over the presentation.
Thanks, Alex. Let me share my screen. Did I share? Yeah, just want to make sure I share the right screen. Mhm.
There we go. Looks good, Lee.
All right. Hello, everyone. Thanks, Alex. And my name is Li Jian, and I'd like to thank Solidspace and the Lidar News for this opportunity to share our journey with Solidspace. And here's an overview of today's presentation. So I'll first talk about why we needed Solidspace in the first place to help with our projects. And then I'm going to dive into case study and other use cases to talk more details about how Solidspace helps our projects to be successful. All right, first, a little bit background about dome construction. So our history started 50 years ago with our first construction project completed in San Francisco City. Over the past 50 years, we've been an integral part of California's landscape. Our footprint expands from San Francisco City to South and East Bay Area and Southern California, like Thousand Oaks and San Diego. Our team specializes in tenant improvements, healthcare, life sciences, and biotech construction. We have a culture that strives to deliver quality services to our clients. And as you can see, 94% of our businesses comes from repeat clients. Our BIM department is an important piece in this equation to help our team deliver high quality services. The department was officially formed in 2020 with a group of highly skilled people that are passionate about construction technology. Since then, we've been leveraging emerging technologies in different use cases from early pre-con stage to project handover. And Solidspace is one of the important tools that we've been using for almost every project. Starting next slide, I'll be sharing how Solidspace helps our project to be successful. A lot of our projects are TI projects. We deal with existing conditions every day. Even though each project is different, we run into the same challenge over and over again. There is no as-built, or there is as-built drawings, as-built models, but they're not accurate. By definition, as-builts are the documentation that should reflect the final product, should be consistent with the field reality. But a lot of times, the as-builts and the field reality, they don't match. But why is that important? Why it is so important to have accurate information regarding the existing conditions? Or maybe we could ask the question in a different way. What would happen if we don't have that? I'm sure all of you could think of something in your experience. I also have one story to share. We had one build-out project. We have coordinated to 3/4 of the scope and got into installation in the field. Then what we find out was the new design didn't fit. What happened was the structure model didn't match the structure in reality. The columns and the beams in the model are not even close to what's in the field. And we're not talking about 1 inch or 2 inch off here. We're talking about beams being off as much as 4 feet. With that being said, we thought we have coordinated the overhead MEP services with existing structure. But the truth is, we have not. To fix this problem, substantial redesign effort was required. After the redesign, we need to go back and re-coordinate everything. It is obvious that the redesign and the re-coordination will have schedule impact, and the client has already paid the design and the construction services that have occurred. All this rework will add a lot extra cost for the client. Because of the substantial schedule and cost impact, the project ended up being shut down. It is unfortunate, but what may surprise you is that this case was not an outlier. We had another project that got into a 6-month delay because of the variances we found later in the field. We learned enough lessons that to have accurate understanding of the existing conditions from the get-go is extremely important. And this is where Solidspace comes into play and adds a lot of value to our process to help us minimize the rework and the risks. Here's a good example. This project is a retrofit project for biotech client. There are extensive existing MEPF services in the space, but we only had a few as-built CAD drawings to start with. And as we expect, the as-built drawings are not true as-builts. Lacking true as-builts is not just a challenge for us, it is also a challenge for the design team and the client. Realizing its importance, the client was asking for BIM deliverables in level of development LOD 500 on this project. In other words, the BIM deliverables need to truly match the as-built condition in the field. In fact, we noticed that more clients in the healthcare and biotech industry start to put LOD 500 requirements in their BIM requirements. So we came up with a workflow that will achieve the client's goal in this project. There are different parties involved and each of them had different touch in the process. But in general, it involves 4 steps. First step is the site scan. We knew from the past experience that we must have an accurate representation of the existing conditions before we move forward. The CAD drawings that we have with inaccurate information are not very helpful in this situation. So what we did was hiring a third party to later scan the entire site to have an accurate capture of the existing conditions. Second is the scan to BIM development and variance report. This is the focus of today's presentation, and we will go through the details in the later slides. The third step is the coordination process, where the design team and the construction team leverages the scan to BIM models for coordination. And the last step is we incorporate the scan to BIM models, the as-built conditions, and all the metadata to develop the LOD 500 deliverables. So as the first step, we scan the entire site. The picture on the top shows the point cloud from the scan. Having a point cloud representation of the site is very helpful because it is very accurate. But the point cloud is not our end goal. We wanted the scan to be translated into 3D BIM models. And there are 2 reasons. First is client satisfaction. Our client requested a final BIM model deliverable to accurately represent the existing facility, not point cloud. Scan to BIM suffices the request. But we did more than that later on. There were other contractors working on the same site, but different projects. We shared the scan to BIM models with them. We wanted to help with their workflow as well. That's part of who we are. We want to do the right thing. Second, we needed a solution that's efficient for the greater team to coordinate with existing conditions. In this case, we have tremendous amount of existing MEPF services. If you have ever coordinated with point cloud, you would know it is not as efficient as coordinating with a BIM model. Because first, the model elements in the BIM model are solids, not points. Second, with point cloud, it is hard to tell what we are having issues with. Are we having conflict with the plumbing piping or process piping? Currently, there is no easy way to quickly break down the point cloud into different disciplines for coordination. With that being said, Solidspace helped us translate the point cloud into BIM models of different disciplines so that we could coordinate with existing conditions more efficiently. Based on our experience, I'd like to share some best practices for scan-to-beam. If you want to have scan-to-beam on your project, here are the 4 things you need to pay attention to. First is to plan ahead. Depending on the scope, it could take a couple days or even a week for the scan, and then maybe several weeks to complete all the scan-to-beam models. Plan it ahead to make sure all the required information is available before scan-to-beam starts, and make sure there is enough time for scan-to-beam development. The second point here is to declare the expectation upfront. What is your goal? Do you simply want to have a spatial representation of the existing services or something else? What level of development do you want to have for scan-to-beam model? How do you want to break down to disciplines? Typically, we would recommend LOD 300, possibly 350 for MEP, unless we want to take over the model and add more effort to it. We also need to communicate the expectation of modeling strategies upfront so that the scan-to-beam model can be manageable for downstream use. One common Revit best practice is to use Revit family rather than model in place to avoid huge file size. In the scan-to-beam process, there will be questions regarding the existing services. Just by looking at the scan, it can be difficult sometimes to tell whether it's a large conduit or a piping, whether it's a plumbing piping or process piping. So plan to do some field verification upfront to identify what's what is very important. Last 2 points are alignment and accuracy. I'll talk more about them in the next few slides. Alignment is very important. Whether you're using point cloud or scan-to-beam for coordination, it is crucial to make sure everything is properly aligned. To accurately align the scan with the beam model, our best practice is to leverage the survey point or the control point. What we typically do is having a survey point etched on the concrete floor to target scan, and then lay the survey point in the Revit model. In this way, we could get an exact alignment between the scan and the beam model. We also find it's helpful to have a conversation with the design team upfront to understand the coordinate system. Is it aligned by shared coordinates or internal? Does the project use True North or Project North? If this is a TI job, we also need to ask if the TI design is using the same coordinate system as the core shell design, and which model shall we use to acquire the coordinates. Understanding the coordinates and alignment will help to set up the project correctly from the very start and make our life easier for the work downstream. But we have to be aware that proper alignment doesn't mean it's perfect. We need to understand the construction variance. And here's an example. The drawing in black is from the scan-to-beam model, which represents the reality. The drawing in color is the core shell design drawing. When the TI design team was reviewing the scan-to-beam structure model, they find out that the columns in the scan-to-beam model, which are the columns in black, were not perfectly aligned with the grid line in the core shell design. They initially thought it's an alignment issue or something wrong with the scan-to-beam model. But the truth is, there's nothing wrong with the scan-to-beam model or the alignment process. What caused the difference is the construction. Construction process is not perfect. It is natural to deviate from the design intent. Understanding the discrepancies, whether they will or will not impact the future work, is what we wanted to know. And this is where Solidspace brings a lot of value to us. Solidspace is able to use their technology to identify these discrepancies in a variance report, which becomes an important QA/QC solution in our workflow. In this particular case, we compared the scan with the scan to beam model to make sure the scan to beam model is accurate. But in other cases where we don't do scan to beam, we compare the scan with the original design model or as-built model to understand the discrepancies. The image on the right is an example of the variance report. The part I like most about this report is it not only tells me whether the model is accurate or not, it also gives me all the details about where exactly the discrepancy is and how to fix it. As you can see, the purple box here highlights the column that deviates from the original design. And the plan view down at the bottom tells me where exactly this column is on the grid line and how much exactly and in what direction it deviates from the original design. It's very simple to read and easy to understand. With all this information, we could then make the decisions of whether we need to fix this or not. Generally speaking, if the difference is 1 inch and above, we would raise the concern and ask for correction of the models. But the fact is, we usually see columns that are off 4 inches to 8 inches, and beams are not set to the right elevation. In these situations, we know if we don't get this model corrected, it would impact the coordination and installation down the road. So what we typically do is reviewing the report with the design team and asking their help to correct the major discrepancies. In this particular case, because we were verifying the accuracy of scan to beam models, Solidspace helped us to fix the major discrepancies. Our clients like the variance report as well. As I mentioned earlier, we see more clients in the healthcare and biotech industry want to have accurate as-built documentation. What Solidspace does offers a reliable and efficient analysis for them to understand how it's deviate from the design intent and to make sure their as-built documentation is accurate. Here's another example. In the Bay Area, structure and seismic support are very important. And this example shows the structural bracing was built differently than the initial design. The orientation of the structural bracing is different. The client had a structure engineer to review the difference to make sure there is no impact to the stability of the structure. Here's another example where the variance report provides the design team with valuable information in an efficient way. The TI architect wanted to verify the location of the existing walls so that they could better plan the layout of interior walls. What this example shows here is the actual wall location has 4-inch difference than what's shown on the drawing. This information saves the architect a field trip to field verify the actual location of the wall. And in the meantime, it gave her the exact information she needs to lay out the new walls. We received the same positive feedback from the MEP engineer. The variance report gives them a quick but accurate understanding of what's on site in reality. It becomes more important nowadays when people are working remotely and they need efficient ways to get the information they need. This example shows the plumbing riser is not at the location as the core shell design shows. We later find out it was relocated to another location during the core shell construction coordination. Floor flatness analysis is another helpful tool. It measures the flatness and the levelness of a concrete floor. After the analysis, we would have a report that includes a heat map like this, illustrating the elevation difference of the floor, and also details pointing out the high points and the low points. We find this analysis to be very helpful in some use cases. One use case on this biotech project was to help the superintendent establish the benchmark point for new housekeeping pads. As you can see from the heat map, the different blues indicate the elevation difference of the floor. The existing floor was built in slope for proper drainage. Our scope of work includes 7 housekeeping pads for new equipment. The client wanted the top elevation of all the new pads to be the same. In other words, the thickness of all the new pads can be different, but they must come to the same top elevation. With the analysis, the superintendent doesn't need to go to the site and do the survey at 7 different locations. Instead, he was able to pull the information from the report and quickly identify the highest point as the benchmark point for all the pads. The other use case that we find it to be very helpful is at some critical areas, like imaging room or OR room. For these critical areas, we would typically have a tight floor flatness tolerance, like 1/8 of an inch in 10 feet, or even less. The floor flatness analysis can be used as a QA/QC tool to ensure the high quality of the final product. In addition to the variance report, the other part I like to use Solidspace is all the information and models are hosted on their web-based platform. Anyone in the project team can easily access the information and the models. For people that work remotely on a project or don't have software like Revit or Navisworks installed on their computer, or simply not used to navigate the model, this is a huge benefit for them to view the site, take a measurement, overlay the point cloud and the beam model to understand what's in the field and what's being designed. As a summary, Solidspace offers an opportunity for us to improve our workflow and help our clients to save a lot of money. Before Solidspace comes into play, our process started with inaccurate information, which led to extensive amount of manual effort on field verification and substantial rework. The ripple effect caused by rework sometimes can be so massive that the project had to be shut down completely. What Solidspace provides is an accurate and efficient solution to help us validate the as-built of existing conditions so that we could have the accurate information to work with from the very start. This is huge for us because it allows us to have the confidence in budget and schedule sooner on projects. Solidspace not only brings value to our pre-con process, it also offers an opportunity post-construction to help us ensure the high quality of the product that we deliver to our clients. For our clients or any project owner, the benefits can be long-term. It helps to deliver true as-built, which will largely benefit the operation and the maintenance and any future retrofit projects. With that, I'd like to say thank you all, and I'll pass it to Alex for closing and a Q&A. So I'll stop sharing.
Okay. Thank you, Lee. So what a great presentation. You really showed our audience here how you can use this in pre-design, getting accurate as-builts, and developing a scan-to-BIM model that you can feel confident of as a single source of truth. So great presentation. It really shows how Dome uses the software in the QA/QC process to deliver high-quality projects on time and on budget. And in fact, 90% of Dome's business is repeat clients. They've done a great job having happy customers and satisfied customers and their ongoing business with this process. So with that, once again, thanks, Lee. Want to offer and let everybody know that there will be a link sent out to everybody that attended here or registered. So they can go to the recording and show to others or pass it on to others to see if you want. If you'd like to get a dedicated product demonstration live for your team, please reach out to me, alex.von.swoboda@solidspace.com. You'll see that in a slide that Gene will show here in a moment. Or if you're ready to go, you can do a proof of concept. We have some very aggressive pricing to do a pilot scan and variance reports on your project. We see this all the time. All right. So with that, I'm going to turn it back over to Gene.
Okay, thank you, Alex. And I second your vote for Lee's presentation. It was one of the best I think I've seen. Excellent information. Okay, so we're going to do a quick round of questions and answers. There's a couple other slides on the way out that I'd like to get to, but let's see if we can. We've got 4 questions in the queue. Number 1, I guess this would go to Alex. How does Solidspace differ from clash detection software?
All right, great question. We get asked that all the time. So there's a lot of tools like Navisworks, which we mentioned.
Right.
It does coordination with the trades, and that is, a useful tool in BIM that people use today. But that's not us. What we're doing is we're beyond that, and we're in the construction space. So as you heard from Lee, is to go through and do a scan to BIM and measure and look at, make sure that reality is correct so they can start doing their design. The other part that is very important that our customers use is the main part during construction. So the fact that you can actually go and do some construction, install some of the trades that we've mentioned already, scan it, upload it, that scan, and compare that to the construction or post-coordination drawings to see what has been installed incorrectly in the field. And that's an ongoing process. So that scan might happen, say, every 2 weeks, and we would turn that report around in 12 hours so the contractor can then pass that on to the trades or do it themselves to correct the things before they get any further along and it gets more expensive. So I think that was the answer, Gene.
Okay, very good. I want to jump down to this one. I think for Lee, how actually does it help with quality control? The concern is by the time it's scanned, it's already been built. It's already in place. So if there's any deviation, you're still going to have to do rework, is the question, the person asking the question. How would you respond to that, Lee?
Yeah, it's a great question. So in my opinion, I think, what I like to use Solidspace is not just that post-construction process. We wanted to, as I mentioned in the presentation, we kind of added a quality control process in our pre-comp workflow. So we use the Solidspace to help us identify the discrepancies of the as-builts of existing conditions so that we know we will work with the accurate information from the very start. So that gives us a lot of confidence about the information that we're gonna use for the downstream work. So that kind of help us make sure that the quality of that information is good. And yes, there's also a post-construction process that Solidspace can help us, ensure the quality of the product that we deliver to our clients in the end. So hopefully that answers the question. So in short, I think it's both ways. We need to use this process pre-construction and post-construction to make sure to ensure that quality we deliver to our clients.
Yeah, sounds good. Alex, is there a storage limitation, storage size limitation to the Solidspace online project site?
So the answer, Gene, is no. So we set up the online application so you can dump those or put those large files for the scans and the DWGs and the BIM files all up there. That comes with the 360-degree photos as well. But no, there isn't a size, and there's no limitation. Just to add on that is on the number of people you can invite to join you on that collaboration site so that you can investigate the model with others, the architects, the engineers, the owners, whoever it might be. You can set up permissions so that they can be regulated as to what projects they can see, but there's no limitation both internally and externally on who you can invite in.
Very good. So Lee, control points, how are those permanently fixed in a construction site? The second part of the question is, should it be used till the end of the project for scanning?
So I'm not sure what causes the issue with the control points, because from what I see from the question, I'm not sure I understand that part. So, but you know, in our case, it really depends on what the goal of using the scan. So if it's using the scan to capture the existing, so I would do it at the very beginning of the project because you want to capture that. But if it's to verify the as-built condition, then that could be done two options, either during the process or after everything is done.
Okay. And let's take this as the last one, and then we'll just wrap up with a couple of finishing slides. For Alex, how do I purchase Solidspace3 for the construction variance reporting capability?
All right, great question. So we, as I mentioned a little earlier, we are a SaaS offering. You're not buying any software. You're not getting any physical thing like that. You are purchasing a quantity of reports. So depending on your project, we have pricing like you can buy one, or you can buy a group of 5, 25, 50, 100. Obviously, the more you buy up front, it would be a little cheaper discount for the more you get at one time. But typically, you'll know, you're doing we just did looking at this project now in the Boston area that's about 100,000 square feet. It's going to be somewhere 35 reports, maybe 40 reports on that. So they have a good idea of, okay, that's what I can do a bulk purchase of X amount. I can use them if I don't use it completely on that project on something else. But you're buying a report quantity and that's it. So you're not buying software or anything like that.
Okay, we had some other ones just come in. I want to catch these. They're important. Who does the scanning, Alex? And if models, pictures, scans are uploaded to Solidspace Cloud, can that data be retrieved at the completion of the project, or does the client need to keep paying hosting fees to Solidspace?
Good. Yeah, so obviously we're very user-friendly in that respect. So I'll start off with the scanning. So the scanning, we are looking for partners. So a lot of the projects we're doing right now, we're signing up partners to do that scanning for us, and they will work on a contract basis to go, and they're very good at, they do this all the time. We just give them a little direction on what we want and the control points, and they will go do the scanning. So, we really don't, we do some scanning ourselves just because we have to, but our long-term goal is to have a whole set of partners in every city, multiple people that could do the scanning for us.
Okay.
To answer your question on the data, yeah, once you're, we give you a period of time after the project ends to then archive the data. We can archive that and then close up the site. So you don't have to pay ongoing costs for storage.
Okay, very good. All right, let's get this wrapped up. A personal interest of mine is working with the younger geospatial professionals in the industry. We have a LinkedIn group, the Younger Geospatial Professionals Group. I encourage anyone on the phone, we're generally saying that the younger geospatial professionals are under 35, but those people all need mentors. So we don't want to restrict it to any age. We need the people who are need the mentoring, and we need the mentors. So hope you'll consider that. And then we want to thank everyone for taking the time out. A lot of people stayed for the whole webinar, which was really excellent. Here are the email addresses. And once again, I hope you will just take a few moments to fill out that exit survey. And I think that's the end of our presentation. So thank you very much, everyone, and we'll look forward to seeing you next time.